Hi and welcome back to Null Zero Labs and part 2 of our Palo Alto High Availability build out. We are back in the same lab as the previous video, which I will leave a link below if you haven't already watched that. In the video, we set up the WAN side of the firewalls, configured the high availability, and we tested the path monitoring and link monitoring facilities that we configured for the WAN side of the interface, and we tested the failover scenario of the device completely going offline, and we saw that firewall 2 would take over for firewall 1 in the event of any of those failover scenarios. What I've added to the diagram to the lab now is a inside setup where we are going to connect each of our firewalls to our switch stack redundantly. So we have two Nexuses down here configured with two VPCs, VPC 10 for the primary firewall and VPC 11 for the secondary firewall. And we will configure an aggregate interface on the inside, and we will set a sub interface of VLAN 20, and we will set up the inside interfaces to also influence our failover decisions. So let's jump straight to firewall 1 and let's get configuring the inside interfaces, and we'll show you what we need to do. So on firewall 1, we've got a couple of things we're going to do first. So if we're going to jump to device and go to high availability, we can see from how we left it, everything is left how it was. You can see that we configured this active passive settings to auto to allow us to keep our secondary interfaces in a standby state ready to take over. And so we're going to have a couple of things we're going to do, because we're going to use the fast failover setup. So we're going to have to make sure we've got a couple of options selected. So let's jump over first to our network page, and we are going to set up an LLDP profile. I'm just going to call this just the default. We'll just allow all the optional things so that we can see it on the switch later. We're going to make sure that LLDP is enabled. So let's add our aggregate group. We'll call this aggregate group 1. We can support 8 on this firewall. And it's going to be of a layer 3 interface. We're not going to be doing any routing or IP addressing on this interface, because we're going to do that as a sub interface. But we are going to turn on and enable LACP. We want active. We are not going to select this because we have, like I said, turned on under our high availability. We've turned on this passive link auto. So we want each firewall to have a unique MAC address for this to work correctly. So we don't select this option under this section here. We're then going to jump over to advanced. I'm just going to turn on and select the LLDP profile that I created. And that will be enough for our aggregate interface down here. Now we're going to assign E1/2 and E1/3 to our aggregate interface group EA1. And we will do the same for 1/3. Okay. So that gives us our internal physical connection here. Obviously this side I've pre-configured. We will log on there later so that we can check the port channels. So we've created that. Now let's create our sub interface for our VLAN 20. So we want to add a sub interface. 20, and we're going to tag it as 20 because it is a trunk down to the switch. It's going to be part of our default group, and we're going to create a new inside security group for this. So we'll call this VLAN 20 security group. We're going to give it an IP address because it's going to be the gateway for our VLAN, which was 10.21.20.254/24. We're not going to be using IPv6 or any SD-WAN. We will allow ping on that interface just so that we can test that it's up. And so we hit on OK. So what we've created now is our internal aggregate interface with our layer 3 sub interface, and we've assigned our 2 physical connections. So let's commit that so that gets synchronized over to firewall 2, and then we will move on to the next bit. Okay, if we jump over to firewall 2, we can see it's synchronized. And if we come over to our network tab, we can see that we've got the exact same configuration in place. But on our secondary one, we can see that our physical interfaces are held in an up state, but we can see our aggregate interface is being held down, as it is not the currently the active firewall. You can just double check LLDP did get turned on, and we do have our LLDP profile. So what we should be able to do now is we should be able to go over to our switch and confirm that we have the VPCs up on the switches. So let's just do that quickly so we can verify. So let's log in as switch 1. We'll do the show port channels first. Port channel summary. And we can see that port channel 10 on switch 1 is switched, and it is up. And then we can see that the member interface E1/1 is up. And then we can see that port channel 11 is in a suspended state, and the interface going to firewall 2 is also in a suspended state. So let's check firewall switch 2. Show port channel summary. Again, we can see that port channel 10 is up. Port channel 11 is in our suspended state. Okay. So now if we do show LLDP neighbors, we can see firewall 1 is there. And obviously firewall 2 is currently being suspended, so we're not going to see it. Let's just double check as well on switch 2. Show LLDP neighbors. Yep, we can see firewall 1 is up. So we should, just cutting in here, editor Matt here, is at this point, whilst editing the video, I realized why I wasn't seeing the sub millisecond failover. If we look in this screenshot here, I'm missing during our configuration of the virtual Palo Altos, we are missing the option to enable HA in a passive state. And this is what I am working to as I'm making the video, as I'm used to doing this with the physical hardware. And obviously, being the poor YouTuber that I am, I can't afford to buy 2 Palo Alto 3260s to sit here and demonstrate with. But if Palo Alto are out there and watching and would like to donate some, I'll happily accept. But if I'd enabled this option, we would see, when we looked at the LLDP neighbors, we would have seen both firewalls up and visible. And what we would have seen, like we see later in the video, is that we would see that both firewalls would have a unique MAC address for that physical aggregate interface. And that is what caused the slower failover procedure whilst we were waiting for MAC address tables to be updated on the switch. But anyway, back to the video, and remember, if you haven't already, hit the like and subscribe button. Now, to jump onto one of our test machines, bring up PC 7 and 8. We should now obviously be able to ping each other. Ping 10.21.20.7. From PC 8, we can ping because obviously they're on the switch. Let's ping our gateway address, which we configured as 20.254. And we are reaching that, which is our firewall gateway IP address. Okay, so we've got connectivity to our interfaces. So now let's configure our firewall on firewall 1 as we would with a policy and an outbound NAT so that our test machines can reach the internet. And then we will then configure the port monitoring for those interfaces. So let's start with a security policy. And we'll just call it the internet. And the source is going to be from our VLAN 20. We have a source address of 10.21.20.0/24. Going to our outside interface with any address, and we will just allow any application for now. Oh, what did I miss? Source address, destination address, application default, allow. Oh, I messed up the source address. Typo. 10.21.20.0/24. There we go. Typos. And then we will add our outbound NAT, our SNAT. And our original packet is going to be coming from VLAN 20. Going to outside. It's going to have a source address of 10.21.20.0/24. We're going to translate that to our outside interface of the firewall, which is on Ethernet 1, and that's its public IP. So we will commit that, and then we will test that our test machines can reach the internet fully. Woohoo, that's saved successfully. Let's close that. Obviously, it's going to be synchronizing over to firewall 2, but we should now be able to jump onto PC 7 and 8. And we should now be able to ping Cloudflare, which we can. Perfect. So we know our firewall is working, and we're able to successfully go redundantly through our redundantly set up switch to our redundantly connected firewalls to our redundant internet feed. And now to make sure our failover happens if we were to unplug both of these, we would still want to failover. We wouldn't want to keep this as the primary, because if we was to unplug both of these at the moment, there would be no failover. If Ethernet 1 or the path to the VRRP address on the WAN side was to go down, obviously firewall 2 would take over, because we've configured path and link monitoring for this interface and for this path. So what we're going to do now is we're going to configure link monitoring only for this side, because this is layer 2 here. There's no address that we're going to be monitoring. So there's no path address for us to monitor. And we wouldn't want to monitor one of these PCs, because if we switched it off, it would be unreachable and the firewall would fall over, which is not what we want. So we're going to jump up to firewall 1. Let's go over to our device and high availability. We're going to come back over to our link and path monitoring, and we're going to add another link group. So let's add one, we'll call it downstream. Okay, and then we're going to add our two interfaces, which was ETH1/2 and ETH1/3, which make up our port channel interface. Now, we want our failure condition to be all. because if one of them gets disconnected, we're just going to reduce in bandwidth, but we can still operate. So if we say all, we're then expecting both of these interfaces to be completely down, then we will fall over to firewall 2. So that's all we need to add for our internal. This is obviously monitoring our path to our virtual router. And this is monitoring our link of our outside interface. So we will commit that. And then once that's committed, we have to remember to jump over to firewall 2 and add that as well, because we're going to want to also monitor that interface in case firewall 2 takes over. And again, if its interfaces go down, we're going to want it to fall back. Okay, so I'm on firewall 2 now. And if I go over to device and we come into the link and path monitoring, we can see it didn't add this section when we synchronized. You obviously have to come in and set up what you would want to each device to fail over for. So that's why these are unique to each of the devices that you're configuring. So we're going to add now our downstream one on this side. And again, I'm adding it because we already know what's going to happen if our device falls over anyway. Oh, let me edit that. Remember, we want all of them to, if all of these interfaces go over, then we're going to do that. So let's commit that. The reason in this scenario it's not really too much of an issue is because we are preempting anyway. So at the moment, if firewall 1 was to die and come over onto firewall 2, it's only going to do it whilst firewall 1 is offline. Once we bring firewall 1 back online with our current configuration, and once the hold down time is complete and everything's stabilized, firewall 1 will become the main active firewall again by default, because that is how we have configured it. But in a scenario where you don't set it up like that, and you set it up so that if there's a failover, this firewall takes over, it's going to stay the active state until something causes a failover. Either you manually make a failover to make firewall 1 active again, or if a link fails, or if these links fail, you're going to want it to fail over. So by doing that, we're sort of like saying, hey, at the moment now, if I was to go and turn this off and just set them so that, like I've just explained, so that one, it doesn't automatically fall back to one device being the main one, you can guarantee that if there was that failure scenario of this going down, you know it's going to fall over. But for our intensive purposes, when we test and we drop firewall 1, firewall 2 is going to take over only for that brief period of time that firewall 1 is offline. So we have configured now our internal interfaces, and we've connected them redundantly to our redundant switch setup for both of our firewalls. The interfaces on firewall 2 are set like pre-negotiated, ready to go for LACP if a failover was to happen. We've configured the interface monitoring now as well, so that if both of these interfaces were to be unplugged, the firewall would fall over. If one of them is unplugged, obviously traffic can still file up one interface into the firewall, so we're not going to cause a main firewall fall over just for that. We could bring that interface back online. So we've got everything we need, and everything is configured how it should be. So each firewall has link monitoring. Each firewall has an outside and inside link monitoring group. We are monitoring the path to our upstream gateway on both. We have our HA communications connected for both devices. We have our data link to our for both devices, and our HA keep alive. Under our general, we have our group set up. We're saying that we're an active and passive setup. We have our passive state interface link set to auto, so that keeps our interface is in that state ready to go. And we have configured our election settings to say which one is the primary, which one is the secondary. And we have also elected to turn on Preempt so that our main FW1 will always become the master once it comes back online. So we always know where to go first if we want to put our configuration on. But like I said, in the grand scheme of things, you could just easily just call them firewall A, firewall B, but you would have to remember to go and check which one is currently the active state when you start making config changes. We haven't turned on heartbeat backup. That would do a backup heartbeat sensing via the management interface, and we're not using that. You could use it if you've got a guarantee that your management interfaces and your management network are not going to be flapping or causing any problems. So that is our HA setup done and complete on the firewall. We've temporarily put a policy in to allow us internet access. We can bring up the log viewer. We should see that we sent some pings out to the internet from our internal machine 8 and 7. That is all functional. And we can see we've configured our widgets on our dashboard so we can easily see which devices are the active and which ones are the passive. So now we can do some failover testing. So what we can do now is we can start to send some continuous traffic from these two devices through the firewalls to the internet. And let's run through a couple of failover scenarios now. So we can, we won't be able to simulate the interface going offline, because if I was to shut it down on the switch, the way the virtual software works, it will still see this as live. So the only way to really test that is to kill the whole firewall and switch it off, and we should see the data flow go via the second one. In a real world scenario, we would be able to like unplug the cable and check that the failover that we configured under our link group monitoring would cause the failover condition. But again, working in a virtual environment, we can only really rely on the path monitoring to go down to cause the failover. So let's send some traffic from PC 7. And first of all, whilst we're on the switches, so let's just double check. So we know that firewall 1 is active because again we've turned on LLDP, so we can see that firewall 1 is showing, and it's on the interface. We can see via the port channel summary that our primary is online because that port channel is the one that's up. If we show the MAC address table, we can see that the MAC address for VLAN 20 is currently living under port channel 10. And when we do the failover, we'll be able to see that that MAC address moves over to VLAN port channel 11. So we have traffic flowing from PC 7 and PC 8 out to the internet. So it's going through the switch, up the port channel to firewall 1, and the same for PC 8. It's going up the port channel to firewall 1. It's then making its way out of E1 to our VRRP gateway and out and onto the internet. Let's check our monitoring on the firewall for the internet rule. We can see we have continuous traffic flow, which is what we want. So now let's test again the failover scenario if we lose the path monitoring to the gateway. So to do that, what we'll do is we will shut on the ISP's gateway. We will shut down the interface that's going to our primary firewall, config T, int G0/2. Let's shut that interface. So we shut that interface. Come over to dashboard. Right, okay, we can see the local has gone path down and it's moved the role of active to firewall 2. So now if we look at the monitoring on firewall logs, there we go. We can see the traffic is now going from our devices up VPC 11 now to firewall 2 and out onto the internet via ISP gateway 2, which is correct because obviously we've lost communication on firewall 1. The path is down. Like I said before, we couldn't test pulling out or pulling the interface down because it doesn't shut the interface. Because if we come over here, we can see it's still green electrically. Under the lab environment, the interface stays up. It's unfortunate, but hey. Let's bring that interface back up. And we should see that as we've configured, we will see that we move back to firewall 1. And again, we'll go through this converge process of the port channel being suspended and the port channel 10 becoming the active and up, and then we'll see the MAC address table move, the MAC address for that IP address move to port channel 10, and then we'll see traffic flow continue again. Okay, and back on firewall 1, we can see that the fault is cleared. Firewall 1 has become the active again. And if we jump over to our switches and we show the port channel summary, at the moment we can see that they're both in an up state, but port channel 11 will get will go down. This will catch up and we'll see that the MAC address will move to PO 10. And we'll see when we do an LLDP, we'll see that PA1 will come back into play. Takes a little while for everything to catch back up, but we will see it happen. There we go. MAC address is moved now back over to PO10. Yep, we can see traffic is flowing again. In a virtual environment again as well, this is a little bit slower. This is like worst case scenario. I'd say on the physical hardware, it's a lot quicker than this. So yeah, it's a little bit of time, but it's not a lot. At least you know it will fall over and everything will continue and come back up again. Stop firewall 1. And then we'll jump back to our PC 7 and 8. And then we should see again, we'll lose some packets and then firewall 2 will take over. And again, like I said, firewall 2 takes over near enough instantaneously. It is active. If we check the network interfaces on here, it is up and green. The only thing we're kind of waiting for here is the MAC address stuff, the ARP and MAC address tables to catch up on the virtual switches. And like I said, once that happens, we will see so that's all we're waiting for, is just for this MAC address to move over. And once that happens, traffic will resume. And like I said, it's up, there we go. It's happened. So we're moving again. There we go. So we now have the ability to keep our devices on the LAN continuously connected to the internet based on which firewall is up. Okay. Now that firewall 1 is back up, for a final check, what I'd like to do is test that if we do the failover not using a sub interface and see if that speeds up the failover, because sub interface pre-negotiation is not supported on sub interfaces. So as we've seen there, we've still got a bit of a failover time. So I want to test if we don't use a sub interface, because on this interface here, we are using a unique MAC address for each firewall. But what I'm seeing when we look at the MAC address table for this interface, the sub interface, it's the MAC address is staying the same regardless of which port channel it's moving over to. So what I want to do is I want to test if we remove the gateway and put it on an actual interface, so that this is a access interface with a gateway address rather than it being a trunk interface with a sub interface. Just for testing, just to see how that speeds up failover, because I know in my environments we use sub interfaces under our AE1, and yes, the failover is slower, but not on the level of slow that this is. So that has moved to the actual, it's not a sub interface now, it's at the top level. So that's moved on there. Let's check firewall 2. That's in place and correct. Oh, refresh. Yep, that's correct. Part of that security zone, blah, blah. Let's just check the policies, make sure we don't need to update anything there. We shouldn't need to because it's using the security groups, but we're going to monitor security. We're going from this zone to this zone with this address. Then that, we're going from the zone to the outside zone with this address, so we don't need to update anything there. So that's all working. So that should mean that if we check our traffic flow again now from, yep, we're flying on PC8. Let's send traffic from PC1, PC7. So we've got traffic flowing from both of these now through the actual aggregate interface, but this time not a sub interface. So now let's test. And let's also, yeah, so now let's test if we shut down. Firewall 1 is currently the active. Stop firewall 1. So it's down. Okay, we see it go down for a couple of pings. Let's check firewall 2, dashboard. Refresh. Firewall 2 has become the active network. It's probably because we don't have, yeah, we don't have the pre-negotiation ability to turn that on here. Okay, but that's up. Still no change there, so let's show MAC address table. Show MAC address table. PO10. Bad beef. Bad beef. Bad beef. Bad beef. Okay. Think it's the software. Yeah, bad beef. It's moved. Okay, we should be back up, and we are. Okay, not really much difference. Okay. So again, I think as well on the software-based version, I'm pretty sure that when you create, pretty sure on the hardware one, there is an option to say when you enable it, you want it to pre-negotiate the LACP. And again, I don't think, again, because it's the software-based one, I don't think it's what would we call this? We'll call it an issue, but more niceties of using virtual rather than physical hardware. Just double check under here. Ah, there we go. Yes, that's what I'm missing. So under the virtual environment, we're not able to use the pre-negotiation, which would speed up the failover. What we would see is that on the MAC address tab, we would see this MAC address change for each of the interfaces, and by doing that, we would see that the interface that when we bring it back up, we'll see we bring this firewall back up. If we look at when we do the show port channel summary, we can see that this one is in a suspended state. But what we would normally see in the hardware environment when we turn on the enable HA passive state, we would see this would also be up. It wouldn't be suspended and down. It'll be up, pre-negotiated, but it wouldn't pass any traffic. So that's why we've got that slower failover. That's why I was wondering. I was like, I'm pretty sure there was a tick box. And yes, there is. On the hardware firewall, there will be the option to enable that option, and we would get the faster failover. But what you would find is that even if we were using the physical hardware, that option's only going to take account when we're doing it at the top level aggregate interface. Once we add a sub interface, each one of those sub interfaces is going to have its own MAC address, and it's going to be the same MAC address that will move between devices. So there'll be a delay waiting for that MAC address update to happen on the switching environment. So I suppose it's just one of the downsides of using virtual hardware. We cannot do a full HA pre-negotiation, so you are going to get downtime whilst we go through changeovers. Not by a lot, but it's not going to be sub millisecond. Whereas if we do it and we enable the HA pre-negotiation mode, we should see like sub second like fall over. Interesting. You learn something new every day. But hey, what we've achieved in the lab over the course of these 2 videos is everything that you need to configure a highly available Palo Alto pair. Just note that obviously under the hardware scenario, it works a lot better than it does in the virtual environment. Remember, you want to aim to enable the pre-HA negotiations so that your interfaces on the secondary are up and ready to go in the event of a failover, that they have a unique MAC address so that you're then not waiting for the delay of the ARP entry being removed from your switch before the address moves over. So that's the thing that causes the longer changeover delay when we're doing the testing in the virtual environment. But other than that, we've covered setting up the HA pair. We've covered the port monitoring. We've covered the path monitoring. We've tested failover scenarios. We've covered using Preempt to make sure that you know which firewall is always going to be the master. We covered why you'd want to use that if you want to use it. And we've tested all of those traffic flows whilst we've gone through those failover scenarios. So hopefully that's helped you understand Palo Alto HA. I've obviously learnt the bit there at the end where we have to use the where it says that you have to use the same unique MAC address for the virtual environment, and obviously it was doing that anyway, but it just wasn't taking the one that we were specifying. But I will play around a little bit more with that off camera, and I'll report back any findings on the social media if I'm able to speed it up in any way, shape, or form. So please hit the like and subscribe button if you haven't done so already. It helps me know that people are watching the videos, and I'll see you next week with something else. So have a good one. Bye.